Hello guys, welcome back to Industry 360. In today's topic, we will try to understand what is dimensionality reduction. So let's begin. The first question is, what is dimensionality reduction? In machine learning classification problems, there are often too many factors on the basis of which the final classification is done. These factors are basically variables called features. The higher the number of features, the harder it gets to visualize the training set and then working on it. Sometimes most of these features are correlated and hence redundant. This is where dimensionality reduction algorithms come into play. Dimensionality reduction is the process of reducing the number of random variables under consideration by obtaining a set of principal variables. It can be divided into feature selection and feature extraction. So let's try to understand what are the reasons to reduce the dimensionality. Quicker and more accurate results from machine learning methods is done by reducing dimensionality. Computational issues with large number of predictors, inability to use certain statistical methods when not enough observations per predictor exist, less accurate results if the data is noisy. So as you can see in the figure, the X data is converted into Y data, and you can see the Y data is more simplified and easier to visualize. Now let's try to understand what are the components of dimensionality reduction. There are two components of dimensionality reduction, feature selection and feature extraction. In this way, let's try to understand what is feature selection. We try to find a subset of the original set of variables or features to get a smaller subset which can be used to model, predict, and solve the problem. It usually involves three ways: filter, wrapper, embedded. In feature extraction, this reduces the data in a high dimensionality space to a low dimension space. For example, a space with lesser number of dimensions. What are the methods of dimensionality reduction? The various methods used for dimension reductions include principal component analysis, linear discriminant analysis, generalized discriminant analysis. We usually do principal component analysis for dimensionality reduction. As you can see, this is the example of dimensionality reduction technique. We have 3D plane data which is converted into 2D plane data after using dimensionality reduction technique. That's all in the dimensional reduction video. I hope you understand something from this video and stay connected to Industry 360. I'm going to make more videos in the series of mini bytes.